Okay, so first of all, I want to point out that these notes that look like this is the TVM calculator note, so you might want to put that at the top. And then these notes that have this little graph on it, this is the one that's about annuities. All right, so the beginning is just giving you a visual of the difference between a lump sum investment, which is basically what the TVM calculator notes were, and an annuity investment. So what I'm highlighting in yellow here, this is the lump sum, okay, which basically means it is a one-time deposit into an account, and then you are not touching that account the entire time that it's in there. So it says the following shows a lump sum investment of $1,000 earning 10% compounded per year versus an annuity with an initial investment of $200 earning 10% compounded per year and additional $200 deposits made each year. Okay, so then in pink, so we can see that the first year we make an initial deposit of $200, and then even though we start off with a much smaller amount in the annuity, it increases over time a lot more than the lump sum investment does. And so this is the power of annuities, is that where if you dump it in there and then you just leave it in there, it doesn't increase very much over time. But if you're making regular payments into the account, it increases a lot over time. Which basically, this is what you did in part 3 of the project. You calculated by hand, if you were making deposits every year into an account, how much would that be at the end of 10 years? But what we're going to look at here is a faster way to do that rather than using Excel and having to calculate it by hand every time. Okay, so scooch down. And we're going to take a look at this. So this is basically going to have us use the TVM calculator in order to solve this problem. So it says, okay, we're still using the same information. We have a $200 annuity over the 5 years, and then I'm pulling this from the top. Okay. So at the top it says that this account is compounded yearly. Okay. So that means that n is equal to 1. Olivia, stop talking. Okay, we are making $200 annual payments. Okay. It's at a 10% interest rate. And it's for 5 years. Okay, so capital N stands for the number of compounding periods between the time of the investment and the time of retirement. So it's compounded yearly for 5 years. So you multiply those two things together. Okay, it's your lowercase n times t. Which, of course, 1 times 5 is just 5, so that one's easy. Okay, your interest rate, you are going to leave it as a percentage. So before, when we were doing it by hand, we kept having to convert percentage to decimal. When we're using the calculator, we are not converting. Leave it as 10 for 10%. Okay. The principal or present value is whatever your initial deposit is. So we're making an initial deposit of $200. And then we are also making regular payments of $200. So PMT is going to be negative 200. Notice that these are both negative because this is money that you are giving away to put in the savings account, into the annuity. So if it's money that you are giving away, you put that as a negative. Okay. All right, the future value we don't know. You're going to leave that as 0 for now, but we're going to come back to it. And then PY and CY should be the same. They are the number of payments per year and the number of compounding periods per year. So it compounds once a year. Okay, this is your N value. And then we're going to make this annual payments as well. Okay, so it's $200 annual. Okay, so that means once a year. Okay. Also, because we want these things to be the same, I want you to write this. To make PY equal CY, make the number of payments per year match the compounding period. Okay. All right, and then up here it says, note that interest is typically paid at the end of the compounding period, but you make payments at the beginning of each period. So when you are doing annuities, you have to change the PMT button to set it to beginning instead of end. So I'm going to show you, I'm going to reset my calculator and show you how it begins from scratch. So on my calculator, here is your purple apps button. So you press that. Then you hit finance and TVM solver. Okay, bless you. You can multiply this inside of the thing. So like 1 times 5 we know is 5, but if it's something different, you can multiply it in there and it does it for you. Okay. Our interest is 10%. This is going to be -200 and -200. We're going to come back to this, okay, because this is what we are solving. These are both 1. And then this PMT, you are making your payments at the beginning of each period instead of the end. So change it to begin. Okay. Okay, and then to get your answer, if we want the future value, you're going to go back up to the thing that you want, which is the FV. And then notice that on your enter button in green, right above it, it says solve. So if you press alpha, the green button, and then enter, it will solve for this thing. Okay. So I'm going to press alpha, enter, and that's my answer. Okay. Okay. So our future value is equal to 1665.22. All right, and then flip to the back and we're going to look at a couple more examples. Do y'all have any questions on the front side before we flip to the back? All right, back side. Okay, so this one says that Amy is 25 years old and has attended some retirement planning seminars at work. She's starting to think about retirement savings. Okay, so she plans to invest in an annuity earning 5% interest that's compounded annually. She's going to save $100 from her monthly paychecks so that she can make annual payments of $1,200 into the annuity. We're trying to determine the future value after 35 years. So what we're solving for in this problem is the future value. Okay. This is what you're going to have to do alpha enter on, is the FB. Okay, so then our Compounding, we're compounded annually, so lowercase n is 1. The time is 35 years, so this is going to be 1 times 35, which is just 35. Interest rate is 5%. PV, we don't have any initial deposits. We're just making regular payments. And so even though she's saving monthly, she's depositing annually. So this is the amount of her PMT. Okay? And then remember to make that number negative, because that is what you are putting away right now. So you're giving that money away in order to get it back later. Okay, and then PY and CY are both 1 because they should match whatever your N was. Okay, N was equal to 1. And then set it to beginning for an annuity. All right, so I'm going to put this into my calculator. So 1 times 35 is just 35. Interest rate is 5. This is 0, negative 1,200. I'll come back to that, okay, because we're going to solve for that later, but you have to put everything else in. So this would be 1 and 1 in beginning. Okay, so I'll go back to this, alpha enter, and then this is what we get. Okay. So we get 113,803 and 59 cents will be our future value. All right. You ready for the next one? Can I scoot down? Okay. Okay, we're going to skip over number 5 and we're going to go straight to number 6. Okay, Amy finds another annuity account that accounts for monthly compounding and monthly payments. Okay. The annuity pays 6% annual interest, and then the time is we're saving for 40 years, and this time we know what we want our future value to be. We want the future value to be $850,000 at the time of retirement. What we're trying to figure out, it says determine the monthly payments. So this time, the PMT is what we're solving for. We want to figure out how much we need to be depositing every month in order to earn this amount in the future. Okay, so then if it's compounding monthly, then N is 12 this time. Okay, T is 40 years. So you multiply those numbers together for capital N. Okay, 12 times 40. Okay, and that gives us 480. The interest rate is 6%, so you're going to type in a 6. Oh, I meant to write alpha enter here. There is no initial deposit, so the PV is going to be 0. Okay. And then I'm going to temporarily make PMT 0 because I'm going to come back to it in a minute. We want the future value to be $850,000. And then both of these would be 12. Okay. Okay. So check that everything matches on your calculator. So we've got 486, 00, 850, 12, 12 in beginning. Okay, and then what we're solving for is the PMT. So press alpha enter, and then we get this, negative 424.69. So what that means is that this is how much you would have to deposit into the savings account every month in order for it to earn that $850,000 in 40 years. Okay. Okay. Y'all ready for the last one? Okay, last one. All right. So this time we are accounting for weekly compounding and weekly payments. The annuity pays 5.25% annual interest. She decides to put $1,000 from her graduation money up front, so we do have a present value this time. We have an initial payment. And then we're trying to calculate and change that from monthly, change that to say weekly so that it matches the compounding period. Okay. Amy needs to make over 40 years to have $850,000 in the future. Okay, so this time in is 52. The time is 40 years, so 12 times 40. 52 times 40. Okay. Interest is 5.25%. We do have a PV this time. We're making a $1,000 initial deposit. PMT, I'm going to come back to this because that's what we're solving for. Future value, we want to be $850,000. And then both of these would be 52. They match whatever your in is. Okay. So 52 times 40 gives us 2080. Interest is 5.25. PV is negative 1,000. Okay. 850, 52, 52, and then beginning. Okay. Once everything is typed in, go back up to the thing that you're solving for. Okay, and hit alpha enter to calculate. Okay. So we get negative 118.63, which means she would need to make deposits of $118.63 weekly. Okay, so weekly she is making that into that savings account. Okay. All right. Do y'all have any questions about how to do those kinds of problems? Okay.